Mulberry, Morus alba, is commonly propagated through stem cuttings to maintain desirable plant characteristics. This laboratory experiment investigates how cutting type and rooting hormone application influence root and shoot development. The study aims to determine the optimum conditions for successful mulberry propagation.
Four trays were prepared using a 3:7 ratio of organic soil to sand as the growing medium. The flowing cuttings with 3 to 4 knots were prepared and the basal ends were cut at slant. A. Woody cuttings with leaf where the leaf were cut in half. B. Woody cuttings without leaf. C. Softwood cutting with leaves with the leaf were cut in half. And D. Softwood cuttings without leaf. For each cutting category, the cuttings were divided into 4 groups. A. Softwood cutting and B. Hardwood cutting, and both are with rooting hormones where the basal end were dipped in auxin hormone for 10 to 20 minutes. C. Softwood cuttings and D. Hardwood cuttings, and both are without rooting hormone. After 2 weeks, the cuttings were carefully dug out to observe any root formation. Rooted cuttings were labeled with a thread. The date was recorded and photographs were taken. The cuttings were continuously observed and the rooted cuttings were labeled bi-weekly. The dates on which new leaf formed were noted. In the 8th week, the root length and the number of leaves on the cutting were measured for each treatment.
Hardwood cuttings without hormone showed successful shoot and root development because contained high carbohydrate and nutrient reserves. Had mature, lignified tissues with well-developed vascular systems. Possessed sufficient endogenous auxin. Maintained an optimal auxin-cytokinin balance, supporting both root formation and bud break. Were more physiologically stable and stress-tolerant under greenhouse conditions. Hardwood cuttings with hormone appeared almost dead because already had adequate endogenous auxin. Hormone application caused auxin overdose. Excess auxin inhibited root elongation and bud activity. Hormonal imbalance disrupted root-shoot coordination. Increased moisture retention at the cut end may have promoted tissue breakdown or rot. Softwood cuttings with hormone appeared almost dead because were highly sensitive to exogenous auxin, leading to hormonal imbalance. Showed increased metabolic demand without adequate energy reserves. Experienced phytotoxic effects, such as tissue necrosis or excessive callus formation. Remained vulnerable to water stress, despite hormone treatment. Softwood cuttings without hormone appeared almost dead because had limited stored carbohydrates, leading to energy deficiency before root establishment. Experienced high transpiration and rapid water loss due to tender tissues and thin cuticle. Failed to initiate roots quickly, resulting in wilting, chlorosis, and tissue collapse. Lacked sufficient endogenous hormones to trigger adventitious rooting.
For optimal condition, cutting type, softwood stem cuttings. Softwood cuttings showed higher rooting percentage and faster establishment compared to woody cuttings because they contain actively growing tissues with higher physiological activity. Presence of leaves. Stem cuttings with leaves produced better root and shoot development than leafless cuttings, as leaves continued photosynthesis, supplying carbohydrates and endogenous hormones needed for root initiation. Next, rooting hormone, auxin, application. Cuttings treated with rooting hormone exhibited earlier root initiation, longer roots, and increased rooting success, indicating that auxin effectively stimulated adventitious root formation. Growing medium, soil, sand equals 3 to 7. The well-drained soil and sand mixture provided good aeration and appropriate moisture balance, preventing waterlogging while supporting root growth. Last but not least, environmental condition. Shaded and moist nursery conditions reduced water stress and desiccation, improving survival rate during the early rooting stage. Overall optimum condition. Softwood stem cuttings with leaves, treated with rooting hormone, planted in a well-drained soil. Sand medium, 3 to 7, and maintained under shaded and moist conditions provide the most favorable environment for successful mulberry propagation.